Good evening, all. Stand by for the OMARC Sunday Night Science and Technology Net. This is W2NDG. I am just getting the stream going and getting situated. All right, here we go. Good evening. This is W2NDG, Neil from Highland, broadcasting on the OMARC repeater on 146.805 with a negative shift of 600 hertz and a PL tone of 103.5. We will pause for any emergency or priority traffic. Nothing heard. Always a good thing. Once again, this is Neil, W2NDG. We meet here every Sunday night at 8 p.m. and talk about science and technology. Tonight, we're going to dive into radio a little bit more, as long as we decide we want to do that, and I'll explain in a little bit. But we did start talking about radio last week and kind of what it meant to us and what interested us and how we got into it. And I thought we'd start with a little more tangible things this week, but that's going to depend on the audience because it is starting to lead into summer and summer vacation time and everything else here. And let's see if we have people who, a lot of people who check in tonight. If not, I think we may just have an open discussion instead, which I do have a subject which is related to where we were going to go, but we'll see how that works. So we meet here every Sunday night at 8 p.m. This is the 14th net in a series, and we took over from CJ when he moved out of the area, who was running a net called the All Things Natural Net about more farming and farming technology and plant related. Which we did have a net on a similar subject one night, but we miss CJ and we miss his net. I could never replace him. Let me try. It was a busy weekend for a lot of us. We participated in the Hudson River Radio Relay. Our station was at Kingston Point Park, and it was a good exercise in setup for something other than field day and operating something other than a contest. The special event station is something different, and we learned a lot, and we had a lot of fun, and we got to see a lot of good people, and love to do it again. So that was great. I'm usually joined here by Jim, K2BHM, who acts as co-host, and we're going to ask Jim to check in first and see if he's around tonight. Jim, are you there?
Thanks, Neil. I'm here. K2BHM.
All right, cool. I'm glad to hear you're here. I think I mentioned today was kind of a lazy day once I got a lot of things out of the way, but my son came to visit, and we wanted to spend some time with him and his girlfriend. Even though he doesn't live so far away, we don't get to see him nearly enough. So that was fun. So I just kind of threw some things together here. But like I said, a lot's going to depend on our audience tonight. Let me pause for a sneeze. Thank you. And of course, I can't pause the audio on the YouTube, so I apologize for the open sneeze on camera. Let's see who we have tonight, and we'll do a couple of rounds of check-ins, but I don't want to really spend a lot of time on my beginning radio series unless we have a good audience. So let's see who's around. If you'd like to check in to the OMARC Science and Technology Net, come with your call sign, your first name, and your location. Please come now.
This is November 2, Foxtrot Zulu Charlie, Tom and Fishkill. This is KV2RWW, mobile for Hudson. Bob. Here is K2LD, Bob in Tazeville. I just ran back upstairs fresh from pouring a new adult beverage, so I'm ready to go. Here is KB2 GGF, Matt in Kerhunson. Good evening. This is
That last station was very weak. You get in a better spot or pump your power up, but I was unable to make out the call. All right, was that KB2TAT? I know we've had you on here before, so I was able to recognize that. Let me just pause for verification. All right, I believe it's Steve in Poughkeepsie. Hopefully you can get to a better spot when we come back around. But yeah, your signal is very low today. Is there anybody else who would like to check into the net tonight? Please come now. Okay. What I wanted to talk about tonight, without getting into a lot of the basic radio theory, and we're not going to really bore everybody with a lot of stuff they already know, but we're going to talk more about, applications and the things you might not be as familiar with. But I wanted to talk about the frequency spectrum and what, the things that are there other than ham radio, things we take for granted, things on bands that we don't really know much about. And I thought we'd start at the bottom and work our way up. So there's definitely a lot of interesting things on the low frequencies, but the low frequencies have interesting properties. We'll discuss what's different about them, and also the negatives and limitations, which is why they're actually good for certain things and not good for others. So there's definitely a lot to be listened to down there, and there's actually some amateur radio use for these lower bands as well. Now, when I talk about lower bands tonight, we're going to start basically talking about things that are down around 30 kilohertz and up, and we'll first talk about 30 kilohertz through about 530 kilohertz. Let me drop. W2NDG on the OMARC Sunday Night Science and Technology Net. This range is sometimes called long wave. It can also be referred to as LF, or low frequency, in the upper parts of it, and VLF, or very low frequency. There's also other interpretations of that. You don't really want to tear this apart to that level. We're going to look at it as a whole, but there's a lot of different things going on there, and things you may not be aware of. So it should be interesting. Let me throw it over to Jim for some comment, and he can relate some of the things he knows about how the really low frequencies behave when we use them. Jim, pick it up. This is W2NDG handing it to K2BHM.
Thanks, Neil. Well, the first thing that comes to mind is, if I remember correctly, doesn't WWD transmit also on 60 kilohertz? And that's what all of the atomic clocks use for their calibrations, because it's easily available and, I don't know, just there. Does that ring a bell?
Definitely, and it's one of the things we'll hit on. There actually, years ago, used to be two frequencies that the National Bureau of Standards ran on the extremely low frequencies. There was currently we have WWVB, WWV Bravo B, and there used to be a WWVL also. There were two stations down there. WWVB, you are correct, runs at a frequency of 60 kilohertz. And I'll get in a little bit into what it actually does, what it's used for. Back to you, Jim.
Yeah, that did ring a bell. Lots of clocks have a 60 kilohertz receiver in it, and they use the WWV signals to correct the time and keep it on schedule, or keep it accurate. But from what I hear, that signal may be going away.
Well, it's possible. They have been threatening to defund WWV. And of course, there is a lot of modern technology that has replaced it. But there was a bit of an outcry talking about, what would happen if it went away. So for now, there's been some funding put in place to save it. But we'll see what happens going forward. So WWVB, as we said, operates on 60 kilohertz. This is not something you're going to tune into like WWV and be able to hear what's going on. It actually transmits data at the rate of 1 bit per second. And in 60 seconds, it sends the current time of day, the date within a century, and a number of different ways of identifying the exact time. So the carrier is varied at exact intervals. And there are devices that can tune into this and get the correct time and date out of the signal. Of course, we have other ways to do that now. Let me drop. There are a number of devices that get correct time somewhere else, like in your car. If you have a system that draws off of the satellites, your time is coming from there. If you have a device that's tied into the cellular networks, it's usually getting its time off of the cell towers, which is pretty accurate, but not as accurate as an atomic clock. GPS time is extremely accurate, and a lot of portable devices or devices that can't be otherwise connected to a really exact time source, GPS is the way to get correct time now. But some of you may have seen over the last couple of decades, really, some of the devices that came out, like a wall clock that said that it would automatically set itself, or sometimes some clock radios that did. And a lot of them were actually using WWVB. And they would even tell you that it may take a day or two for it to actually sync up correctly, because it was monitoring the signal, and sometimes it's not a very strong signal, and it has to get enough of it to be able to reconstruct the time. So, interesting stuff. I'm not sure exactly what WWVL was, but it was a similar purpose. And at some point, I'll have to look that up and read up on it. Let me drop. Jim, I don't know if you're aware of anything else that's down in that extreme lower part of the band, but there is definitely something else down there that was very important for many years, and I think it's still used to some extent, but not as much. I wasn't sure if you knew what that was.
No. The one thing that I was thinking of is Loran C ship navigation, which was on lower frequencies, but I don't think it was that low.
Not quite that low, but it was down there. Yeah. And that was another one. It was ship navigation. One of the properties of extremely low frequency waves is that they're very penetrating, and they're good for getting through things that regular radio waves might not be able to. One of the things they're not good at is modulating a lot of information. Hence, WWVB taking an entire minute just to communicate the date and time. At the extreme low end of the radio spectrum, they used to use those frequencies to communicate with our submarines. And I believe they still do, but not as much as they used to. And that's another thing that I'm not 100% sure of. And one of the great things about doing a net this way is that somebody else on here may know that answer. But subs were using that type of communication. The messages were very slow and encrypted. And there was also the basic form of data compression used at some of the frequencies, because there's just no way you could get enough information sent forth through this type of format in a safe amount of time. If you were trying to get a submarine to react to something that was immediate, obviously you didn't want to use a format that would take 10 minutes to send 3 words. And once again, I'm just pulling these numbers out of the air. I haven't done the deep research, but submarines used these types of frequencies to communicate, and may still in some cases. So let me drop. And does anybody have any information on subs using extremely low and very low frequency waves? Well, that's fine. And we can come back and talk about that aspect of it in another net even, because I will be looking some of that up. And I apologize for my lack of research today, but we were off doing things a lot of the day, and it wasn't very planned. So it's one of the reasons why I say let's see who we get on the nets this time of year before we really delve into a subject, because it's summer and people are out doing things, and people don't necessarily get in time to sit here for an hour or so, or they're exhausted from mowing the lawn and taking care of trees and everything else we do this time of year, and that's fine. There are other time signals in that range from other places all around the world. We're not the only ones that do this. So that's other things that exist down there. So let's talk about a couple of other uses for this band. And one of them is something called NDBs, or November Delta Bravo. Does anybody out there know what an NDB is? And you can tell me. Throw your call sign out. Okay, that's fine. I happen to know what these are, and I've listened to them. And, with any hobby, there are definitely people off in the fringes of that hobby. For example, my father, when I was growing up, my father collected stamps as a young man, and then he got back into it years later. But he didn't collect any stamps. He didn't collect international stamps. He didn't collect stamps from one specific country. Although they were U.S. stamps, they weren't just regular old stamps. They were pre-canceled stamps, which I don't think even exist anymore. But in the days before being able to print postage and the Pitney Bowes postage meters becoming so widely used, there were pre-canceled stamps that you could buy for your post office that would allow you to get mail into the system faster and a little cheaper. And he collected those. So it's the same thing with radio. There are definitely fringes in this hobby that people get involved in. Let me drop. This is W2NDG on the OMARC Sunday Night Science and Technology Net. There's people who do moon bounce communications. There are people who settle into slow scan TV. And what this is, NDB stands for Non-Directional Beacon. And a non-directional beacon, and this is another part of the radio hobby that is slowly disappearing, but it used to be that located somewhere near an airport, not necessarily at the airport, would be a long-wave transmitter. And that transmitter would transmit a Morse code identifier, usually in AM mode, on a specific frequency, and it would repeat its call in Morse code every certain number of seconds, and then the carrier would stay present. The idea is that you would null that signal out with a directional antenna, and you would know, you would get a line for that null, and perpendicular to that line would be where the signal was coming from. They were used as aviation navigational aids, and it was the way that they found the airports. It was one of the ways that they found them, because if there, for some reason, line of sight wasn't working correctly, or other instruments, it was a way of verifying. It's a way of getting a direction. So aircraft had these directional antennas, and they could zero in on these signals. Let me drop. You'll see that some of them still exist, and what's interesting is that there were a group of radio enthusiasts, not necessarily hams, of course, but people from shortwave and broadcast listening who collect NDB logs. And depending on the organization that owns the particular station, sometimes they will they'll QSL. You can send them a reception report and get a QSL card back. It's been known to happen. The one I knew around here, and I don't know if it's still on the air, was just north of Goshen, New York, and it was the one placed for the Orange County Airport. And that one was very close in frequency to 335 or 330. I think it was 335. It was close in frequency to 330. And the reason why I knew that, let me drop, is because it was close to a frequency that was almost exactly half of WFAN 660. And at that point in time, I was driving for a living, and I would listen to Imus in the morning on 660 WFAN when he landed on there. And as I drove down Route 207 near Goshen, there was a spot in the road where the station would fade out and Morse code would fade in. And I didn't understand what was going on at first, but then I realized that I was getting the harmonic of the station, and it was so close to it that it was bleeding over to 660. Should have been transmitting on 670, but I was right on top of it. So that's the second harmonic of 335. I think that was the frequency of that one, but I'd have to look it up again. I don't know if it's still on the air. I haven't checked in a while. But if you want to play with NDBs, let me drop. If you have a radio that tunes down that far and you have an antenna that's able to pick up those frequencies without a ton of interference, you can tune around, usually between 190 kilohertz and 530 kilohertz in this country. Usually not below about 280, but you can turn around in sideband mode and listen for the carriers. And then once you zero beat that carrier, you'll hear a string of Morse code letters. And they'll spell out a call sign, usually 3 letters, sometimes 2. And you can look that up in one of the NDB lists and figure out what you're getting. And they have propagation as well. And like I said, people collect these, and you never know what you're going to hear. One more drop with this. A good radio, just portable radio, if you want to go out into the field away from the interference and play around with something like this, would be one of the older shortwave radios that has the long wave band going down to about 150 kilohertz. The Sony model ICF 2010, the Sangean 803 and its Radio Shack twin, and some of the other Radio Shack and TechSun and Grundig radios that all went down to 150 kilohertz. Sideband is not necessary to listen and get the signal because they're usually AM, but sideband is good for finding them because you'll hear that that beat, that carrier beat. All right, so that's something you'll find down there. Jim, any comments on the subject before we move to the next little thing?
No, actually, I don't have any experience with that. Mine was more recent aircraft VOR Omni, and those systems, which are pretty much now obsolete because of GPS.
Exactly, and so much of this hobby has disappeared, you know, as technology grows and changes. We've talked before about, you know, international shortwave radio stations, broadcast stations, and how many of them have disappeared because people don't use shortwave for getting news abroad anymore. They use the internet, they use satellites. The use of shortwave radio for utility use or military communications, business communications, government communications has also dropped off because of all the alternatives available. It's still there because in many cases it's the backup, and they still have to run all their drills and all their tests to make sure it's working. All right, the next thing I'm going to bring up is amateur radio use. Let me try. So this started with something called LOFER, L-O-W-F-E-R, LOFER. And you were capable as a ham of getting an experimental license to operate a LOFER station. It says unlicensed use in the guide that I'm looking at, but I thought that you had to get an experimental license to do this, but maybe I'm wrong. But loafer stations, I think the unlicensed ones were below a certain power level, and possibly you needed the experimental license to use stations above that power level. And the loafers were located in the 160 to 190 kilohertz range. I don't think they could go over 1 watt, and you were limited in antenna size as well. A number of years ago, though, we started pushing for some bands down in this range, and we got them. And if you don't know about them, you can look these up. There are 2 hand bands in the VLF and LF ranges. Let me drop. W2 NDG on the Sunday night OMARC Science and Technology Net. So we received, as I said, 2 bands, one being the 2200 meter band, 2200, the other one being the 630 meter band. And I believe, I'd have to double check this, if you're a general or higher. I would have to double check. But you can use either of these bands. The 2200 meter band in this country is 136 kilohertz, and it's 136 to 139 kilohertz. That's a very small swath of spectrum. But you're allowed to use up to 1 watt of radiated power, and they're pushing for other limits and rules on this band, but it would mostly be used for slow-speed data transmissions. Things like slow-speed Morse, Whisper, and other data-only transmissions. Voice doesn't work well at those frequencies anyway, but we really don't have enough bandwidth to be using voice down there. So it's the 136 to 139 kilohertz. Let me pause for comments unless somebody has more info on the regulations there.
USDC, it is general or higher.
Thanks, Tom. Appreciate that. That's what I thought it was. It's just in the particular crib sheet I'm using here, it did not say. The other band we're talking about is 630 meters. 630 meters is 472 to 479 kilohertz. A little bit more spectrum than 2200, but still not a lot. The neat thing about this band is this band's going to behave a lot like the lower part of the medium wave AM broadcast band. So you can kind of get an idea of what's going on by checking propagation there. Same use, basically, although I believe you're allowed a little more flexibility on the 633 meter band. I don't have the actual breakdown, but United States 472 to 479. Stations must be separated at least 1 kilometer from electric transmission lines that carry power line communications, PLC signals. You do have to register before you start transmitting on that band, because they want to make sure you're not going to be interfering with PLC. So there is a registration site. You can find information about that on the ARRL website. Maximum power is 5 watts this time of EIRP, which is effective radiated power. Transmitter output power not exceeding 500 watts. Let me drop. CW, RIDI, data, and it says phone and image emissions are allowed, but I don't think a lot of people are using phone on that band. there's not a lot of bandwidth, but I haven't played with it yet. I think I would like to. You do need special equipment. Most of the radios that we own won't do this. Let me drop. But a lot of them do. And it's kind of interesting to look in how you can do this. There are transverters available, mostly in kit form. And you can modify a couple of the existing radios on the market to work on these bands, one of them being the ICOM 7300. But you do need some output filtering to make sure that you're legal. So that's another little thing you have to add on. Let me drop. Tony Parks, the creator of the Soft Rock kits, makes a low frequency and VLF version of the Soft Rock RX-TX. The last couple of times I checked, it was not available. You can probably email Tony and find out if he's going to be offering them again. He only sells those pre-assembled because part of the assembly is very tricky, and he prefers to sell them assembled to make sure that they work. It's almost the same as his standard RX-TX unit, but the bandpass and low pass filter modules are very difficult to wind. If you've ever seen some of the toroids I wound for the kits that I was doing, they get larger and have more windings as the frequency goes down. You can imagine what the toroid for one of these frequencies would look like. So, but that stuff is available. You can definitely do the modifications to some of the commercial rigs to operate on these bands. Also, if you're going to do this, let me drop. Please research antennas. It's a good way to cook your radio if you're not using a proper antenna. I don't think your auto tuner is going to be able to handle these frequencies as well. So it's a lot of learning, but it is something that I've wanted to do. And as I venture into it at some point, I'll have to report back on my own findings. These allocations may change. We originally wanted more spectrum. They've pointed to different parts of the band where they were going to put it at times. And this is where we've landed for now. As some of these pieces of spectrum become used less and less for important communications, we have more of an idea of whether or not we might get some of this spectrum at some point. So far, the FCC has been pretty stingy, as have some of these other organizations around the world. But the fact that they gave up any of it was a good sign. So maybe we'll get a little more. But something interesting to play with. Let me drop. Broadcasting. So when we think of broadcast stations on the lower bands, we think of AM radio. But other parts of the world use long wave for broadcasting, mostly Europe. And there still are some long wave broadcasters. Most of them have disappeared. But the BBC and Irish Radio Service and a number of other countries still broadcast on those frequencies. If you want to get a taste of it without having to set up a crazy antenna and going off into a low noise field, check out, as you know, we have the ability to listen to software-defined radios from around the planet. Check out the Kiwi Sdr Project and find a station somewhere in Europe and tune all the way down into those nether regions of broadcast. And what you may find from between 153 and 279 kilohertz, there are stations there, and they're channelized, spaced every 9 kilohertz. So they're all spaced 9 kilohertz apart. And like I said, one of them is the BBC, and they have quite the powerhouse, and it's pretty much heard all over England and most of Europe. So they've been threatening to shut a lot of these down. Russia killed all their long-wave broadcasts not long ago, and a few other countries, but they're still there. And if you want a real challenge, try to pick them up here. Plenty of people do it. Once again, good radio, low noise, good antenna. W2NDG, throwing another break in. This is W2NDG on the OMARC Sunday Night Science and Technology Net. I'm going to throw it over to Jim real quick. We'll see if we have any more people checking in, and then we'll go around the circle with some questions and comments. So, Jim, we've covered everything below our AM broadcast band in the U.S. And I know there's more there, but I'm trying to keep it simple. You can really get into this stuff pretty deep, but that's most of what you're going to hear down there. What do you think about so far?
Well, actually, I don't have much experience down there. Most of my ham life, I've been working 6 meters and above. Antennas are easier when you live in an apartment or stuff like that. So that's where I've been playing. Did a little bit of listening when I was a kid, but nothing below the AM broadcast band. I did hear, about 40 years ago that there was an amateur band, 160 to 190 kilohertz, but never really got into it. It was so demanding for antennas and stuff like that that it wasn't feasible for me. So I pretty much stayed up on the FM 6 meter and above.
Well, that's fine, and that's a lot of us. I only became aware of the existence of those two new bands, but the fact that we were even trying for it. I had heard about loafers. It's not something I ever really thought about much, but there's actually a number of places around the radio spectrum where people operate license-free on an experimental basis. So it's interesting stuff. It's out there. Yeah, the antennas are weird. You're looking at, for most of us who don't have the room for the kind of antenna this would really require, coil loading, which is, if you look up the projects, and I'm going to check real fast in the middle of talking, but I believe there is a website that can give you a lot of information about operating on these new bands. Let me see if I can find it. Nope, not what I was looking for. I will find it, though. So let's see if there's anybody else who would like to check in tonight. You check in by giving us your call sign, your first name, and your location. Please come now.
This is KB5BV, Moe's in Marbletown. WJL.
WJL, if you did that second transmission as well, I didn't catch that, but I got your call sign, KB2WJL. And if we could get your name and your location from the spot where you sent the first transmission out, that would work great.
Yeah, the second transmission was that. My name is Daryl, and I live in Newburgh.
All right, we got you, Daryl. And if it's any help for direction, you're aiming your antenna at the Northern Catskills in Woodstock. That's where the repeater is. And good evening, Mose. It's good to hear you on here tonight. All right, we've been talking about the bottom of the radio spectrum, what's below the AM radio band, and all the things you can do down there. I'm just going to go around here and no specific questions. If you have a comment, if you have any experience with long wave, you've heard of it, you've heard of these new handbands, you want more information, you want to maybe start some sort of discussion about all of us getting together and maybe setting up one radio somewhere that we can do this with and play with it. But whatever you want to talk about, we'll go around. So Tom, into FCC, you first. Your thoughts on all of this?
It's all incredibly interesting to listen to, but for someone who just got their license maybe a few weeks ago, it's merely something that at this point I more just enjoy listening to the general discussion, and I appreciate it, like you guys being on the air.
Oh, that's fine, Daryl. So we go around in a circle. You logged in late, so I'm calling the call signs in order, but that's fine. And yeah, we've been doing this for 14 weeks, and we are going to get into a lot of more basic radio theory at some point. But Jim and I have to sit down and really work some of that out. But some parts of it that we don't consider, and some parts we take for granted. So, but yeah, this is all not just parts of ham radio, but we were talking about the things that exist in the radio spectrum in general. So I called out to Tom. I'm not sure if he's still there, and that's N2FZC. Tom, are you there? Do you have any comments on anything?
N2FZC set to step out momentarily. Comments, well, I'm aware of the VLF stuff, and it is, again, another niche in ham radio that, you could be doing satellites, you can be doing 10 gigahertz, or you could be doing the very, very low stuff. And pluses and minuses, it penetrates, like you said, it can go on underwater, or, you don't really worry a lot about skip with that, but the amount of data you can put through is inverse to frequency. If you're going to do a packet, the 2 meters is 1,200 baud, but then if you go higher, you go 96 or higher. You get more throughput on your data with the higher frequencies. So there's a trade-off there. But it is definitely interesting stuff, and it's also interesting to think about. Other than AM broadcast, FM, TV, and radio, all the other stuff that is in the electromagnetic spectrum. It's my 2 cents. I'm sure I'll see you back tonight.
All right, thanks. And yeah, it's also there was a ratio of technology level to frequency in a way. It took us a while to at the dawn of radio to get up into the higher frequency ranges. They weren't available to us. We didn't know what we were doing. We really didn't know exact frequencies. I was curious, what frequency did Marconi use for his original experiments? And we actually don't know. The answer that comes up when you research that is around 500 kilohertz, but they don't know for sure. So interesting stuff. Of course, later on, we got a little more precise with everything. Thanks, Tom. Bob, KB2RWW, I know you were mobile before, and usually we'll go to mobile stations first, but so much time has passed since you checked in that it probably wouldn't make a difference. But if you're still there, do you have any comments or questions about everything so far?
KB2RWW, I'm going to bow out of this one. I am in the repeater dead zone.
All right, Bob. Still sounding good, though. This is W2NDG on the OMARC, Sunday Night Science and Technology Net. Thanks, Bob. We'll check to see if you're there again later. But if not, have a good evening. K2LD, Bob from Tannersville. Your comments and or knowledge on any of the activity below the AM radio band?
Well, I don't have much knowledge on it, that's for sure. I don't really know how useful any of this stuff is. As
far as the 135 kilohertz or the 472 kilohertz, I don't really know what you can really do with it. Like you said, the equipment is somewhat a project to do, and I guess if you want to go down that direction, that's fine. But what can you actually use it for? Is really my baseline question. I mean, what is it for?
Well, I believe one of the advantages, and you're right, there aren't a lot. And a lot of times, the answer with a lot of what we do is because we can, or just because we're curious. There's a lot of things that technical people do just because it's, experimental. They want to know how things work. But I believe, and I will throw this out to Jim because I think he'll agree with me, what you get in these lower bands is consistency. They're not as dependent on atmospheric conditions. Is that correct, Jim?
I'm not sure. I haven't played with them. I just did the math. If you're talking 160 to 190 kilohertz, you're talking roughly 2,000 meters. So the wavelength is 2 kilometers. So if you put up a half-wave dipole, that's a kilometer. So you got to put up an antenna 5/8 of a mile long. Of course, you're going to make up some kind of a loop or something like that, but that puts it in perspective. But I'm not really sure how propagation is, how it would be affected by atmospheric conditions, lightning, stuff like that. It's something that I have never done before.
Okay.
Go ahead, Bob.
I don't think anybody is going to practically put up a kilometer-long antenna. And if the normal setup for an antenna is a half wavelength in height, that really puts it totally out of anybody's normal category, unless you're going off a mountain somewhere. There's got to be some sort of compromised antennas that these can really be used for, but what is the actual transmission mode? And why is it that you have to register with the power company if you're only putting out a watt or two?
Well, on the one band, affected radiated power, I think you're limited to 5 watts, but you can actually, because of the losses with the types of antennas and everything, you're actually driving with more wattage than that. But if you're in close proximity to one of these systems, you can affect it because of how these the waves at those frequencies operate and how much they penetrate. So you're giving them your call sign, and that way, if they felt that the problems that would come up would be few and far between. But if they felt you were right on top of one of these stations or nodes, or that if a problem arose later on, they could, because of the nature of the license or the allocation and how it's been written for US hams, they could basically tell you, no, you shouldn't be using this. That's all. They don't want people interfering with it because I believe it's in some places how they're controlling the grid. Let me drop. As far as practical antennas, so no one's going to use a full wave or even a half wave antenna on these frequencies. Usually they are special coil loaded or coil antennas. If you think of an AM radio station, the transmitting element in a radio station is not a full half or even quarter wavelength. For example, WCBS AM out of the city has a wavelength of 340 meters, or 1,115 feet. I don't think it has an 1,100-foot transmitting element. So there's all sorts of tricks they use when they do that type of transmission. You can get antennas and build antennas that are loaded antennas for this type of use. When I say consistency, obviously you're still subject to some atmospheric conditions like lightning, as someone mentioned, and other electrical aspects, but let me drop. Radio waves at that low frequency are very predictable as far as other conditions. They're going to act a certain way during the day and a certain way at night. And that's not as affected and volatile as like the bands that we normally deal with. So I think that's another part of it. The practical use for years was the ability for these signals to penetrate through walls, through forests, through water in the case of the submarines, which is why they use WWVB for the clock synchronization. And it's also that consistency. That signal is almost always there, even though you may not be able to hear it with your own ear. The equipment that uses it can. And the submarine communication, as Jim mentioned very early on, LORAN was a ship navigation system that used those very low frequencies. Not quite as low as what we were talking, but still way down there. And that's why it's that consistency. Let me drop. We'll put it back over to Bob for any final comments before we move on.
You can just move on.
That's all right. I hope we answered some of that. Once again, it's different. It's something we don't talk about. It's something we don't know a whole lot about. So that's what we're doing here. Matt, GGF, any comments or questions on everything so far?
Well, you got me curious about what was going on way down low on the frequency spectrum, and my receiver here says it tunes down to 50 hertz, and the display confirms that, and so I tuned from 50 hertz up to 530, and I'm not sure if it receives or just displays that, because I didn't hear anything except there was a strong carrier around 320, and but no data on it, no carrier, no voice or CW or anything discernible. So my antenna doesn't receive it, or there's not much going on that I can receive. But interesting thing. I'm sure, that the Navy does still have a capability of very low frequency communication. They tend to keep things as a backup, I think. Back to that KB2GG.
All right, Matt. Yeah, it's hard to find stuff down there without the right kind of antenna. But some of it's down there, and like I said, you'll come across these NDBs. It'll look like a very small carrier signal, and when you zero beat it and either listen through the missing beat once you zero beat it, or switch to AM mode, sometimes you'll hear a little Morse code in there, and you can figure out which station you're picking up by the call sign. And they're out there. I'm looking at the display on my 7300 right now. Obviously, I don't have an ideal antenna for doing stuff like this, but there's a couple carriers floating around. Also, for those of you that play with digital modes, and here's an interesting thing you can try. Even though you don't have a proper antenna for transmitting, you can receive. And there is whisper going on the 660 meter band, the 472 to 479 band. And if you use WSJTX, set it to whisper mode and set that band and just leave it on all day, receiving. Just make sure you don't have it set to transmit. Well, with most of your radios, it's not going to transmit unless you've opened it up. But see what it gets. You might be surprised. And usually it's overnight that you'll collect some signals. And you might be surprised with how far away you got them from. But it's just something else to play with. That's all. Well, thanks, Matt. Steve, KB2TAT. I don't know if you've gotten to a better location or not, but we'll give you a try. For any questions or comments so far.
Neil, hi. This is KB2TAT Steve. I hope I'm coming in better now. I'm on a different radio. First of all, thanks for the IMUS reference. Listening to IMUS in the morning was always kind of a guilty pleasure of mine. I don't have too much to add to this discussion other than maybe like 20, 25 years ago, I remember reading an article about ELF and how the Navy was burying cables on the bedrock of Maine and Nova Scotia, like literally miles of cable, so that they could communicate with submarines. And I think it was all part of, sort of fail-safe protocols. But like that's the extent of what I know about it, and whether it's still in use, I don't know. The other thing is with MTV, I think the CW codes are still.
Steve, KB2TAT, you dropped out. Your signal was great up to that point, but you dropped out and disappeared. So let's see if you're still there. You were talking about the codes being transmitted.
Roger, Neil, I was talking about the NDV codes that I think are still listed on the FAA maps for commercial and private pilots. Before that, I talked about an article I read about EFL systems where the Navy was placing miles and miles of cable underground on the bedrock of Maine. Back to you.
I heard that part, and yeah, I mean, obviously for any type of transmission, a full wave antenna is perfect. But as Jim said, the 2200 meter band would require a 2200 meter antenna. That's 2.2 kilometers. Yes, that's a big antenna. There are places in the world where you can pull that off, though, and that's probably one of those things that we're thinking of there. All I could say is, wow, it's a lot of antenna when you get to that point. There's certainly stuff to listen to if you're curious. And another thing that you might find down there is another little thing is there's atmospheric effects in the extremely low frequencies, sometimes referred to as spherics by radio enthusiasts. Things called whistlers and other interesting sounds that are caused by static discharges in the atmosphere, but not what you're normally used to. Not like listening to lightning on the bands, just those static crashes. You can actually hear tones and whistles and all sorts of crazy sounds on the extremely low frequencies as things happen in the atmosphere. So another little thing you can hear going on down there. But thanks, Steve. And yes, the second generation of Imus's show on the sports station there was definitely interesting. And when I drove for a living, it kind of occupied the time in the morning. So neat stuff. W2NDG on the OMARC Sunday Night Science and Technology Net. Next up would be Mose in Marbletown. Mose, any information or questions or comments on anything so far?
Good evening, everyone, and thank you for the topic this evening. It's very interesting. 160 meters is as low as I have ever operated. Need to get down on those other bands and explore that. It sounds very interesting. So maybe
Well, thanks, Mose. And yeah, right off the bat, like I was saying, one of the things you can do is tune to 474.2 kilohertz and watch for the whisper signals. And sometimes they are there. I've got a little noise filter box on my IC7300 here. And one of the things is I think, even though I am trying to filter out the noise, these signals are so weak that I'm probably filtering them out as well. It's one of the features of the whisper mode and some of the other WSJTX modes is that they are capable of being decoded below the noise floor, which is just fantastic stuff. And we might talk about digital modes one night. Daryl, KD2WJL, I know we just spoke to you briefly, but we'll just close with you on the round trip around our check-ins here. And if you have any other questions or comments, and you said you were a new ham, you're welcome to come on this repeater and join us anytime. I'll mention all the different nets that we have on this repeater at the end of the net tonight. So Daryl, come now with any other questions or comments that you had. Right, that's okay. We love having new hams come on, and Daryl, hopefully if you're still listening, we'll catch you for one of our other nets every morning at 8:35 a.m. and every evening at 6:30, 7 days a week on this repeater. So, and real quick, is there anybody else who would like to check in to the OMARC Sunday Night Science and Technology Net? You can come now with your call sign, your name, and your location. Nothing heard. Okay. So Jim, K2BHM, now that you know that you don't need 2.2 kilometers to put up an antenna, do you think this is ever something you'd want to play with?
Not really much down there that would catch my interest. Yeah, you can do antennas like with the ferret core and the multiple winding and all that, like they do it on AM radio and so forth and so on, but not really much down there that interests me. I'm happy up in the 6 meter and above range, chatting back and forth with people. I don't know. It was an interest back 40 years ago, but nothing ever materialized, and haven't heard anything about it since until tonight. So that's kind of the story from this end. K2BHM.
That's fine, Jim. And that's the thing about this hobby is that people fall into little niches and different aspects of it. Some people do everything. Some people just do one particular thing. We have operators that only operate CW on HF and nothing else. We have people who only do digital modes. There are people who never go beyond doing VHF and UHF voice. And there are people who devote 80% of their time to doing things like moon bounce and meteor scatter and other, crazy modes. So it's one of the things we love about this hobby is that it is that diverse. But this is an aspect that really doesn't get talked about much, so that's why I wanted to bring it up. But there's other stuff down there. For those of you that have these radios laying around that you don't use, and you never knew what the long wave band was for, well, that's what it's for. And, for those of us that do listening DXing, before we got our ham licenses, trying to see how many AM radio stations we could get on any given night or day. And some of them would actually respond to reception reports. This is just another aspect. It's another thing to listen for, another thing to collect. And although I'm interested in it, I never really got serious about collecting NDB logs. There are people who do this. There used to be a whole column in Monitoring Times for it, where the guy had his NDV logs for the previous month in every issue, and used to talk about what was going on down there. So just something else to listen to. The real catch for the layperson who has a decent radio, something you can try for, something you might want to listen for, is pulling one of those long-wave broadcast stations from Europe, usually in the wee morning hours, with a good radio, a good quiet radio, and a decent antenna. So those of you who like to get up several hours before the crack of dawn can give it a try and go out into a noise-free area and play around and see what you can get. I think only once did I ever do it, but I don't really try seriously. But once again, there's people who do this and not much else. Let me drop. As we run out of low spectrum, we move into something else. And I'm not going to go really deep into this tonight. But the next thing that falls as you go up through the radio spectrum is medium wave, or as we simply call it in our country, AM, or AM broadcast. AM broadcast stations here run between 530 and 1710 kilohertz, and they are spaced 10 kilohertz apart. Every 10 kilohertz, there is a channel, and there are stations assigned to those channels. Some channels are assigned for special use, some are assigned for general use, and some are assigned for more low power and local use. And this is something you may not be aware of, but some of the frequencies are referred to as clear channel frequencies, and that would be stations like 880 WCBS AM, 770 WABC AM, 660 WFAN AM. Is there a reason why they chose those frequencies like that, multiples of 11? I don't know. It's interesting, though. But it stopped there, at least at that time. Those three frequencies, for example, are clear channel frequencies, which means that there are very few stations assigned to those frequencies. Let me drop. Because those stations run high power and they run a very large antenna pattern. So at night, WCBS can be heard states away. If you're into AM DXing or you like to listen to AM radio still, you know some of what I'm talking about. If not, if you haven't played around with it in years or you haven't played with it at all, a good example would be at night when the AM radio stations have propagation that allows them to go much further. Find WCBS on 880 AM. And in this part of where we are, you're going to be facing your radio north-south. And as you turn the radio, because they are directional, when you get that null in the radio, and the ferrite bar usually runs the length of the radio, when you get that null and the station gets nulled out, your radio will be perpendicular to the signal, but the ends of the radio pointing towards its source. So from wherever you are, you're roughly going to be north-south orientation to pick up that station at its best. But there's a reason why I'm saying this. Let me drop it. If you want to get precise, by the way, the 880 tower is near City Island in New York City. There's a smaller island connected to City Island, which has that transmitter on it. If you then, when you're in the null, when you have the radio turned so that you're not getting WCBS that strong, tune your radio slightly higher, just 10 kilohertz up, and you'll hear another radio station on 890 kilohertz, and chances are that station will be WLS from Chicago. And this is pretty consistent. In fact, there are nights that WLS will come in better than WCBS just because of the way the waves propagate. And that's pretty consistent. You'll find you'll get about the same performance out of AM night for night and day for day. During the day, if you're driving in a car with a good AM radio station, you'll get WCBS up the thruway till about Kingston, and it'll start getting too noisy north of there usually. But those are the clear channel stations. Let me drop. There's a lot of frequencies just for general purpose, occupied by stations that might be running as much as 50,000 watts during the day, but they usually reduce power at night, or in some cases for years were completely off the air at night because there were a couple of stations that had rights to that frequency for night use. So their signal would propagate. WGHQ in Kingston, New York, 920 kilohertz was a station occupying a channel like that. GHQ, I don't know how many watts it was running during the day, but it would run no watts at night. It would sign off at a certain point during the night, and then they changed to where they were running extremely low power at night. What's interesting is that they were allowed to sign on at a certain time in the morning, but until, I believe, official sunrise, they had to run that extremely low power. And I remember that. I remember as a kid hearing Bill Skilling say, "Everybody please wait a minute while we put the transmitter up to its full power." And then you would hear the change in the signal. But yeah, GHQ is on one of those kind of middle of the road frequencies. And I think this is divvied up a lot more detailed than what I'm saying, but I'm simplifying it to just 3 kinds. The third kind, AMDXers, AM radio enthusiasts refer to as the graveyard channels. Sounds spooky, doesn't it? Let me try. W2NDG on the OMARC Sunday Night Science and Technology Net. The graveyard channels, the nickname comes simply because they're very hard to DX. There are a ton of low-power local stations on these frequencies. And at night, when you tune into one of these frequencies, if you don't live right near one of these stations, you'll hear this favorite word, cacophony, of radio stations all coming in at once. And we have another local example, 1490 in Kingston, WKNY. If you live in Kingston, you'll get that station at night just fine. But like here in New Paltz, I'm not that far away. I can hear enough of it to make it out because I believe they're running slightly higher power at night than they used to, and they completely redid their antenna a few years ago. But it used to be that, you know, if you were any further away from the station than, let's say, Port Ewan, no, you weren't going to get it. And that's the nighttime power that they run. During the day, the station can be heard down here and a couple other places in the valley. It stretches decently far, but not very far, not a high power station. And that's interesting that when you deal with these low power stations like that, that they actually have better range during the day than at night, just because of all of the stations that are occupying those frequencies. It's a real challenge to DX those frequencies because you really have to play with directional antennas and fading and trying to catch a station when it might just suddenly pull out of the noise for a few seconds and then drop back. But you'll find consistently that you're just going to hear a whole bunch of stations at once on those frequencies. So let me drop. So that's a little info on AM radio. It's still there. It's still interesting. They've tried to make enhancements to it over the years to try to preserve it, and both of the enhancements that they attempted have ultimately pretty much failed. The first one was AM stereo, which worked. The biggest problem AM stereo had was that the FCC decided not to pick a standard. So the standards fought it out in the marketplace, and they said, well, the best standard would win. But that doesn't really work with something like this. So what happened is that some manufacturers went with the Motorola and Motorola compatible standards, and others went with the Con-Hazeltine compatible standards. From a technical point of view, if you talk to a radio engineer, usually they'll tell you that the Con-Hazeltine standard was a better standard from a technology point of view. Let me drop. The Con-Hazeltine format used independent sidebands. And one of the cool things about that is that if you had two AM radios with decent selectivity, but wide enough that you could get some fidelity out of them, you could take on a station broadcasting with Con-Hazeltine, you could tune one radio a little high on the broadcast frequency and the other radio a little low on the same broadcast frequency and get left and right channels out of that. Not great separation, but it worked. You could hear that it was a stereo signal. Let me drop. Most of the car radios that supported AM stereo supported the Motorola format. The Motorola format used more of a multiplexing method, and I don't know the exact nature on it. I just know that it wasn't as well liked by the engineers, but Motorola did a real sell job on the manufacturers, and it's what the car companies went with. So if you bought a car that had a radio that was capable of AM stereo, it was the Motorola system. And you had crazy things happening here in the city where some stations were on one format and some on the other. The only company that was able to sort out this mess was Sony. Sony designed an AM stereo chip that would automatically or manually, depending on the version of the radio, switch from one group of formats to the other. And I had a radio that did it. It had a switch, and in one position, the switch did Motorola and Magnavox, and I think there was another format. And in the other position, the switch did Con, Hazeltine, and Harris. And it worked. You could actually listen to these stations in stereo, and they had a wide bandwidth mode. So if you're getting the station strong enough, you could switch to a wide bandwidth and get fidelity not that far off of FM radio. But the format wars killed it. And Sony was too late with their chip, which could have gone into all those car radios, but it didn't. But the chip lived on. And let me explain that. But first, I'm going to pop it over to Jim for any comments on this so far. K2BHM, anything to add to my talk on AM radio and now AM stereo?
Thanks, Bill. K2BHM here. The only comment was I've never heard the term clear channel used in that mode before. I know up in Albany, WGY 810, they're running, I think they're running 50 kilowatts, and they advertise a clear channel station, but I think that refers to the name of the corporation that owns them, because you see billboards that say clear channel media on them and stuff like that, so I didn't realize that that also referred to a band plan, so news to me. Back to you.
Yes, and you covered a little pet peeve of mine. I was kind of perturbed when that company decided to change its name to Clear Channel because it wasn't always called that. And it's confusing. But yeah, Clear Channel, maybe not officially, but had that meaning for years. It's kind of like when I educated my kids on the difference between brand names and trademarks and actual descriptions of things. That my example was a package of beef jerky that said on it soft and tender, and then if you looked in very tiny letters next to the word soft and tender, it said trademark. People shouldn't be allowed to do stuff like that. So that was the brand name. Great stuff. It's like if we all remember an electronics chain called Nobody Beats the Whiz, that was the name of the store. It had really nothing to do with the fact that nobody beat them, because people are always trying to beat them, but that was the name of the store. So yeah, the WGY, Clear Channel Communications, really has nothing to do with, well, no, it does have something to do with what it actually meant, as they were trying to infer that all of their stations were on Clear Channel frequencies, which they're probably not. But AM stereo. So let me talk about that Sony chip and where it ended up, because it's kind of interesting. At the time, the head of Sony in Japan was a real shortwave listening enthusiast. And one feature that was only available on super, super high-end shortwave receivers was something called synchronous detection. And it was a way of listening to only one sideband component of an amplitude modulation signal, and removing the carrier and reinserting it, later on in the circuit. And what it gets you when you're listening to amplitude modulation stations, either in shortwave or in medium wave, when you listen to only one sideband component of that signal, you don't have to deal with the distortion when the sidebands fade out of phase with each other. So if you listen to AM signals at night or shortwave broadcast signals at night, when they fade, sometimes they don't fade out as far as signal strength as much, but you'll hear that the voices or the music becomes completely unintelligible or unrecognizable. And what's happening is that as the signals fade and flutter, they become out of phase with each other and they interfere with each other. And in the reconstruction of that signal, they get distorted. But if you can isolate one sideband and only listen to that, you don't get as much of the same effect. Now, you can do this with a good sideband rig. You can zero beat an AM signal and get similar to the same effect. But in the old days of analog tuned radios and non-digitally tuned radios, where the frequencies were not synthesized, you had issues with drift, where you would just have to constantly retune that signal. So, but when you do it with sidebands, it's referred to as ECSS, or Exalted Carrier Single Sideband, and you zero beat a signal. A lot of those radios didn't have any kind of wide bandwidth for sideband, so you wouldn't get a lot of fidelity out of it. The whole point of synchronous detection was fidelity, low distortion, and low fading, and it worked great. Let me drop. This is W2NDG on the OMARC Sunday Night Science and Technology Net. So some Sony engineers realized that this chip that they had developed that handled all of the different AM stereo modes, when it was in the Kahn and Hazeltine mode, this is basically what it was doing. It was isolating the left and right channels by doing this with the sidebands. It was actually doing synchronous detection with each sideband and inserting the carriers back in and reconstructing both sidebands so you would get a left and a right signal. So why not take that same chip, that same circuitry, and allow us to switch upper and lower sideband, which in the case of AM stereo is left and right, but in the case of just doing synchronous detection, we call it upper and lower. Why not be able to switch one or the other? So Sony created a radio using this design that was able to do synchronous detection upper and lower on any of the AM frequencies it picked up, from 150 kilohertz to 30 megahertz. And they sold it as the model ICF 2010 2010. It is also one of the longest running models in their history and in the history of portable radios. Let me drop. I forget how many years the radio was made. I think it was possibly up in the 20 mark. The radio was manufactured for a very long time, and it was even a huge controversy when it was discontinued. So, because even to this day, even though it's somewhat primitive electronically compared to some of the modern rigs, it is a receiver only, but it still holds its own next to a lot of modern receivers as far as performance. Really cool radio to have. I happen to have two of them. I have one which I use, one which I had rebuilt, tuned. I'm going to hold it up on camera for our YouTube people. This is actually, if you look at the model on this one, it says ICF 2001D, which is the European version of the radio. And that's one that I picked up. And it's interesting, as you also notice on the back, that the battery cover is a different color. It's because it's 3D printed. You'll find a lot of them when they get sold on eBay are missing the battery covers on the drop. Really cool to listen to AM broadcast with synchronous detection, though. And that's what the chip ended up being used for. There are other radios that had that feature. You'll find some made by a company called Texun. They work, but they do it differently, and they don't do it as well. It's just neat that a radio that was made that long ago still holds its own in the market today. I bought my first one probably around 1987 or so, 88. Had it for years. I had sold it at one point, and then I started acquiring them not long after I got my ham license. And when I say acquiring them, I find them in various states of disrepair. I pick them up. If it's a simple fix I can do myself, I do it. If it's more complex, there are a couple of 2010 specialists in the country you send a radio to, and they do all kinds of cool stuff to them. They replace the dial lights with brighter LED lights. They put some front-end protection in so you don't blow the FETs with static discharge. They fix the battery box problems. They basically turn it into a much better version of itself. So that's what this one that I showed on camera here is. And the other one I have is just a good example that at some point I'll probably put out on a Hamfest table or offer to somebody who wants. They can sell, if you look on eBay, anywhere from $75 to $500, depending on the condition and the knowledge of the person who's selling them. The most expensive ones are usually in the original box in perfect condition with all of the accessories. And they came with a lot of accessories. But great radio. And if anybody has any other curiosity on them, wants more information on them, you can always pop me an email or a comment, and I'll tell you what I know about them. I've used one multiple times in the field doing QRP just to spot for signals sometimes. Just for the nostalgia of it. I certainly have radios that work a little better, but not much better. It's just nice to have a waterfall display, which these don't. It's just a good portable radio in general. W2NDG on the OMARC Sunday Night Science and Technology Net. So I think what we'll do is we'll go around one more time and just ask anybody for their experiences with AM broadcast radio, whether as a kid or whether you still listen to it today. Were you ever an AM DXer? Did you own a transistor radio as a kid? Whatever you want to talk about. But let's talk about AM broadcast radio and whether or not you knew about AM stereo. But first, let's see if there's anybody else who wants to check in. If there's any more check-ins, please come now with your call sign, your name, and your location.
Morning, M3UIQ. Maybe not morning anymore. Paul Rosendale.
This is WA2RKN, Jerry, Hyde Park.
All right, thanks everyone. And I did mention that there were 2 attempts to save the AM band. I didn't mention the other one. I'll just bring it up. It still exists, but it is dying and disappearing, and that is the AM version of HD radio. And if any of you have cars that are capable of HD radio, it does work on AM. The problem is the only station you'll ever run into that's doing it is 1010 Winds in New York City. All the other stations that had it dropped it. But if you are in the city proper, and you really have to be in New York City for it to work, you have to have a pretty strong signal, put on 1010 Winds on your AM radio in your car if you have HD. And it'll suddenly change. You'll get information on the display about the station and what's going on, and it'll come in about FM radio quality, analog FM radio quality. Kind of a neat experiment. It's a shame it didn't catch on, but yeah, there are reasons why it didn't. Radio engineers hated it, but we don't have to get into that deeply tonight. Jim, K2BHM, tell me about AM radio with respect to Jim.
Well, K2BHM here. When I was 5, 6, 7, 8 years old, whatever, my dad had a Mark 5 vacuum tube radio, Air Force surplus, came out of an airplane. So I was playing around with radios like that with 150 volt plate supply and so forth, and connecting up to his 80 meter folded dipole and listening a little bit at night to stuff that was coming in. And the main thing that was interesting is back in those days, we had a radio station up in Albany, WPTR, 1540. Let me drop a second. So they wanted to be big and bold and out there. And they were running about, 110% modulation. So you could pick them up in 4 places on the AM band. They were splattering so much. You could take a speaker and ground one side of it and connect the other side up to, a 10-foot length of wire. And you could pick up WPTR, clear as a bell. Didn't need a radio or anything. Every so often they would get cited by the FCC for violations, and they'd be good for about 6 months, and then they'd crank it back up again. And that's pretty much my experience as a kid with radio. K2BHM.
Oh, cool, Jim. And what did you call the 5-tube radio? What was the term you used?
It was an ARC 5. It was an actual radio out of like a B-24 or B-29 or something like that.
Okay. Are you familiar with the term All-American 5 or AA5 when it comes to the 5-tube superhit radios that were sold? Like, so many of them.
Vaguely. 50C5, 35W4, 12BA6, 12BE6, 12AV6.
Do you know what the advantage was of that design? Why did they come up with that design? And it made AM radios very affordable and very popular because of that.
Well, if you add all the numbers up, you come up with 120 volts, so you don't need a power supply. No power transformer needed. It would work directly off of 120 volts. And there was a certain specific order you had to connect the filaments up in series, otherwise you would wind up with interference.
Excellent answer. And I don't work with tubes a lot, as you know, but I do know something about that particular thing. And yeah, that's exactly what it was. It was a cost-saving thing. And they were able to run these tubes in series like that, and 120 volts, they work perfect. I meant you couldn't take one over to Europe and use it, but and I think the Europeans had a different version of that, let's say. And the same thing, you would have trouble using one of their radios here. What were the negatives of that design? Because there was one huge one.
Well, one side of the chassis was connected to ground, so if you plugged it in backwards, you could have problems. And one other question, what was the predecessor to that particular design?
That I don't know, but yeah, I remember one of my early shortwave tube radios had an outlet on a replacement plug on it. The guy who sold it to me said to make sure that I always plugged the side of the plug with the red dot into the larger hole because he hadn't put a polarized plug on it. And he said, hopefully all your outlets are polarized correctly. And I think once in my life I found a outlet that was hooked up backwards the hard way with an old Sears Silvertone tube radio that I had. When I plugged it in and just happened to brush against it, and felt an interesting tingling sensation. But no, I don't know the predecessor.
Well, before they came up with the 50C5 and the 35W4, they had all 12 volt filaments. And when you add them all up, it doesn't come anywhere near 120 volts. So you had a special power cord. It had a 2-conductor plug, but on the other end, at the radio side, there were 3 wires. So 2 of them were solid, neutral and hot. And the third one came from the hot side of the plug, and it was a resistor wire. So the power cord had a resistor, a dropping resistor in it, to bring the voltage down to the point of where all the tubes would be happy. And if you wound up changing the power cord on it, you wound up frying all the tubes.
Oh, great stuff. Oh, I love this. By the way, John, UUI, who is, I guess, watching on YouTube, put a comment up here that he just passed all the AM antennas in the marshlands, in the meadowlands, when he was taking the bus into New York City. He says AM radio was a lot of fun as a kid. But yes, when you go through that area and you'll see all those antennas in the meadowlands, or as I mentioned, WCBS on that little island right off the coast of City Island in the Bronx. Jim, why are those transmitters there as opposed to on top of a mountain?
Ground plane.
Yep. We love saltwater. You know, as a newly licensed technician, I had a 10-meter mobile. 10 meters was kind of open. I drove to the south shore of Long Island and sat in the parking lot of one of the beaches off season and threw my CQ out, nervous, like first time really doing anything on HF. And the first response I had was a guy from France. God, we love saltwater.
You could do more than make taffy with it.
Yes, we can. Well, thanks for all that, Jim, and cool stuff. And you know, if any of you like to collect radios, it's definitely a night for that. For talking about some of this stuff, I still collect transistor radios to some extent. Certain ones have come to a point where I'm always looking for very special things. So, anyway, Tom, N2FCC, AM radio. Did you ever play with it? What are your thoughts on AM radio?
Hello again, N2FCC Tom here, Fishkill. I'm really fascinated about the history of radio and AM radio, and I did do some in my younger days, some AM DXing. Tune around and in New York, and you get that station from Cincinnati or whatever. Clear channel, they designated certain frequencies that they were not co-licensed. So you run 50 kilowatts or whatever, and then if you wherever you are not wherever you are in the country, but so if you want to get the message out and you broadcast it on a clear channel, you know you're not going to get interference from other stations. So there might be let's say 66 in New York and maybe in California, but not in a lot of the other places. WBNR and Beacon, they run a kilowatt during the day and they drop down to 400 watts at night. And I think years ago they used to drop down to 100 watts at night. But I did do DXing when I went to college in Western New York. Electrical engineering. We built AM radio, and we went up on the roof, put up a long wire antenna, and tuned around, and we did pick up WABC and WNBC. And the other thing, there was a period of time, WNBC, when they were on 66, to get, I guess, a marketing advantage. They like revamped their audio, and the fidelity was much better. That's when they were playing pop music, just like WABC was, and their fidelity went way up. So I think they had the advantage as a music station for a while. But it is especially the co-channel frequencies, which are higher in the band. It's fun to tune around, especially if you got a decent antenna, and see what you can pick up. So radio history is fascinating. Then to FCC.
Thanks, Tom. And yeah, I mean, AM DXing was really my first foot in the door of radio when I was a little kid. Just that for some reason I was fascinated that you could get these stations from all over the place. And my brother had started writing down what he could get. And then I tried to do the same thing. And if you still want to play with it today, you know, those stations are still out there and you can still get really good quality AM radios today or collect some of the vintage ones. And there are aids that will help you get more stations. Still available today are AirCore AM radio antennas. Texan, company I mentioned earlier, makes one. It's a tunable AirCore loop. You put it next to your radio, and it really, really makes a difference. If you want to look for vintage ones, and I have one of these things, not in the room that I can hold up, but the Super Select antenna was about the size of a 12-inch, LP vinyl record. And it was this big plastic round circle, stood up on a little pedestal stand on its edge, and had a big tuning knob on the front, and big gaudy gold lettering and sticker, with the numbers written on it, and Super Select antenna. But wow, they work great. And you put it kind of perpendicular to the radio on the radio side, and you peak it for the station you're listening to. And there's definitely stuff to be heard. Let me drop. W2NDG on the Sunday Night Science and Technology Net. Bob in Kerhonkson, I think you were getting home before, but not sure if you're still there. But if you are, any thoughts on AM radio? All right, that's fine. I believe Bob says once he gets in the house, he doesn't have access to the repeater where he is. So, Bob in Tannersville, K2LD, if you're still there. Do you have any memories of AM radio, or do you still play with it?
I actually still listen to it occasionally. I'm kind of stuck with satellite radio now, so I listen to a lot of that. But before I got satellite, I listened to a bit of AM radio. And are you sure that the New York City radio station was the only one with HD AM? Because I think WGY 810 AM out of Albany still has HD. Because I occasionally get it as I'm coming down the mountain. If I have that station on just to listen to the local news, occasionally all of a sudden it'll sound like an FM station, and the sound quality will pick up, and it'll just be a whole lot better experience. The only other thing that I never really got a great answer to is on the way up to Albany, there's an AM radio station, I think it's 910, on the right side of the thruway as you're going north. And there's 3 towers, very tall, big towers, widely spaced. And I was just curious of why there's 3. And if there's a way of explaining that, that would really be interesting. Why there would be 3 separate towers. They're all in a line, and I'm just not sure of why. I never really got a good explanation of that. That's an end.
Oh, Tom, go ahead. I have a rudimentary answer to it, but you may have a better one. And that station right on the thruway used to be 590 WROW. It may have changed over the years, but that's what it was years ago. Tom, go ahead.
Yeah, so as they say, they phase the towers so they can give the station some directionability. Directionality, maybe. Yes, but by using phasing between the towers.
Yeah, that's correct. And a lot of these stations have to alter their transmission pattern between day and night. Because at night, when the signals go much further, they might be interfering with a station that they weren't interfering with during the day. A great site, if anybody is interested in this kind of thing, and it's also good for FM radio, for seeing the range and what stations you can get and what's out there, is Radio Locator. I believe it has a hyphen in it. I think it's Radio-Locator, but I'm going to check that. Radio-locator.com. It's free, but if you overuse it during the course of a day, you get a message saying that you've done X number of searches and queries from your IP address, and you're done for the day. So you can pay for like a pro version of it, but it's interesting, and it'll give you those patterns. And you can look at the difference between like a daytime and nighttime AM radio station pattern. Kind of cool. But yes, that's exactly what it's for. And also, Bob, I meant in New York City as far as the HD AM stations. It is possible that GY is doing that. But in New York, there were a few, and they've all dropped it except for 1010 Winds. And a lot of it has to do with interference. As the FCC started allowing them to use a little more power for the HD sidebands, they were interfering with other radio stations, especially at night. If you've ever looked at one of these signals on the air, it's pretty wide. So 880 is interfering with 870 and 890 pretty much. So I think that's why it's fallen out of favor for some of these radio engineers. And it's a shame. I wish they could have figured out how to make it work. Back to you, Bob, for final.
I don't think I have much more, but it would be an interesting discussion as far as phasing of antennas go, because I know you can phase transmission antennas on the amateur side, and don't really know much about it, but that might be a good topic someday.
K2VA, Jim.
Go, Jim.
Yeah, it's not so much phasing as it is the antenna base current. When you get your license from the FCC for your radio station, they will determine who you could possibly interfere with and give you parameters as to how much current you can put into each antenna. And from there, you will generate your radiation pattern to minimize interference with adjacent stations. And that has to be closely monitored. And like you say, they might cut back your power at night as well, too. So somebody like WGY, they've got one tower and they're just poking it out. But somebody like WROW, they have to worry about stepping on somebody else's toes. So they have a lot of different regulations they have to deal with. And yes, Bob, I do see HD on WGY, and it comes and goes. So they do have an HD segment of it, too. Back to you, Neil. KTVA, Jim.
Thanks, Jim. Good information. Yeah, WGHQ used to have 3 towers, by the way, in Kingston, because they had to mess with their pattern quite a bit to not interfere with other stations on the same frequency. And at some point, one of the towers, I believe, became dangerously unstable and was removed, and they no longer needed to use that to create their signal. But a lot of AM radio lore, if you really want to get into it. Kingston used to have 3 AM radio stations. There was a third one. Anyway, KB2GGF, Matt, comments on AM radio.
Wow. Let's see. What I am thinking of at the moment is when we're talking about loud AM signals, being in close proximity and not needing a radio.
Yeah, that's quite true. When I was working for the phone company, and I worked in several places, but when I was working on Long Island, when I worked up on the North Shore in Great Neck, and I was working on the splice, and I'd be there for a while, I'd take out my combo test set, those phones that you could clip on with, and I'd clip one lead to ground, which was the messenger wire, and the other lead to one half of a phone circuit that was vacant, and I pick up News Radio 88 just as loud as could be. So I listened to that while I worked. Just data radio. That was kind of fun. And another one, when I was working as a repairman up out of Herkimer, New York, I'd be sent to Little Falls, next town up the river, and they had a very local radio station. It was so local, the tower itself was right in the middle of downtown. So at least once a week I'd get a call to put in an RFI filter into a landline telephone. And they worked sort of. That's about all I can recall at the moment. So back to that.
W2NDG on the OMARC Sunday Night Science and Technology Net. All right, Matt, thanks for that. And yeah, I remember my brother receiving shortwave radio signals on his Panasonic tape deck. I got them on my turntable when I had the turntable located on the opposite end of the room from my receiver. I had grounded them separately, not understanding exactly what that was going to do. And while recording a couple of albums to cassette, got to hear Radio Moscow and the Voice of America in between the tracks, clear enough to hear. But the best story was the East LA one, which I think I told on here a while back, but that was an AM station in East LA that was pumping a very tight signal into the part of East LA where its audience was, and so tight that there was a vacant lot in the middle of that area with a rusty chain link fence that would go kerplink, kerplink, kerplink all day long to the beat of the music. Interesting stuff. And it's all possible. Yes, the receiving radio and the fillings in your teeth, that is actually a thing that can happen. I don't know if it ever actually did, but it is possible, which is where the story came from. Things like that can happen. You can get radio on all sorts of things that weren't even meant to be that type of device, but we can get into that when we start talking about detectors and how this stuff actually works. KB2TAT, Steve from Poughkeepsie, any final comments on AM radio? I know we're running a little late for everybody, and I apologize, but we did get into some interesting stuff tonight. Steve, if you're there, that's fine. Come now. If not, we will catch you next week. So are you still there, KB2TAT? All right, nothing heard. Mose, did I put you to sleep yet, or do you have any AM radio comments?
Yeah, I'm still wide awake here, Neil. Thank you for the entertainment for the evening. I really enjoyed it. AM radio. Boy, when I was a kid, my dad was electronics nut. He really enjoyed it, and he introduced me to the All-American 5.2, All-American 5, and but before that, I got a crystal radio. And let me reset, and I'll tell you that story quick. I got a crystal radio, put the kit together, and at night it got so loud that I would have to take the headphones off because the local stations came in, just blaring. I kept watching a motorcycle cop come up into the neighborhood, and he had this cool Motorola radio and a little Stinger antenna on his radio. So I took my crystal radio, strapped it onto my bicycle handlebars, and I would go to the back of our house to the fence, and I would ground the radio to the gas meter, and the fence was my antenna. So that was my first mobile radio, and I listened to AM stations. So that's my story. Thank you, Neil. This is KB5BZ.
Thanks, Mose. Great stuff. Do you, or if not you, does anybody else remember the name of those crystal radio kits that all of, Edmund Scientific probably sold them. They were in the Sears catalog around Christmas. Radio Shack even sold a couple of them in the early 70s, late 60s. They were plastic. They had like a sliding wiper tuner on a coil. And they even made a transmitter version, which I have one in a box here somewhere. I can't remember the brand.
Man, that's been so many years ago, I don't remember the brand of the one I had. But I had a store-bought crystal radio, and then I got to making my own, and I'd wind coils on a toilet paper roll. So that's what got me started. I really enjoyed that, KB5BZ.
Yeah, I'd have to look this up. I believe the company began with an R, and they made a whole line of these things. And they had like a faux military look to them, but usually in some bright plastic color, red or blue. Interesting things. Yeah, I had the crystal sets and built those for various things. One thing we might talk about as we get into that is that you can actually build crystal radios for things like the AM aircraft band and the FM band. Now at FM, obviously you can't build a frequency modulation receiver with a crystal radio, but you can do something called slope detection and actually receive FM stations with an AM crystal radio. So, and I'm perfectly willing to share some of those projects. They're interesting and they work. All right, Mose, thanks. Let's try Daryl again from, I believe, Newburgh, KD2WJL. Do you have anything to add to our discussion, Daryl, if you're still there? If not, we'll catch you another time. All right, nothing heard. We hope Daryl comes back and joins us again. Paul from Rosendale. You probably have some AM radio stories.
I don't know. I got time building one of those kids. I'm never going to get it from work. I don't know. That's about where my AM radio play with crystal sets went. Out the window until probably about 10, 15 years later. So I get back into this. You'll be able to get Ramsey kits, but I don't think that's the name you're looking for. But, I don't know. I listen to, I go on a lifetime and listen to WQR, WABC, or WOR all the time. So, like, the talk radio shows. I like listening to them guys. But other than that, yeah, 10-3 YQ.
Well, thanks, Paul. And yeah, no, not Ramsey. And they're not around anymore. I mean, the company exists, but they're not making kits anymore, which is kind of a shame. They did put out a large range of stuff at one point. And it was a real shame to see them get out of the business. So, yeah, they are gone. Harry, something tells me you have some good AM radio information to pass along to the group here.
Well, I'm late to the party tonight, so two items. I seem to recall someplace yesterday or whatever mentioning end of the RF spectrum. Did you happen to mention the georesonance of the orb upon which we live? I've often been tempted to try to tune in down there. And if you do a little bit of math on the back of the envelope, it'll tell you that Earth's resonance is about 8 hertz. And I'm getting to understand that there are overtones, such as second harmonic, etc. So, back to that. This is WA2RKN.
W2NDG on the OMARC Sunday Night Science and Technology Net. No, Jerry, I didn't get into that. The thing is, I think I remember reading about this once or hearing about it on another repeater's TechNet, but I didn't get into it because it didn't cross my mind at the time. I mentioned spherics and whistlers, things like that, which are interesting and things you can listen to down there. But didn't get into that, and I wouldn't mind learning more, but probably not tonight as it's getting quite late. I will catch you another time for that stuff. Definitely sounds interesting. QRP Guys was supposed to come out with a spherics receiver, and it was one of the kits that got canceled because of COVID. I think you can buy the boards, but it might be something interesting to put together and see how it works. I also did a little very quick research here, and the company name I was looking for was Remco, R-E-M-C-O. They made these crystal radio kits. They were plastic. They had this crazy looking antenna on top with the brand name on it, and the antenna did nothing. It was just a piece of plastic for looks. They're kind of cheesy feeling, but I believe they command quite a price in the collector's market these days. But definitely cool. Thank you, Jerry. And that at the end of the list, back to Jim for any final comments. K2BHM. Hope you enjoyed tonight.
Thanks, Neil. Yeah, lots of information going back and forth. And thinking back, I remember as a kid, probably 5 or 6 or something like that, I had something that was probably like a crystal radio. And it came in the shape of a little midget rocket ship, probably about 6 inches tall. And you had a ground wire, and then you had an antenna wire, and then there was a little thing on the top that you would pull up and down to tune in the stations. And had a little we want to go with it. And wow, haven't thought about that in decades. Have no clue what the name of it was or anything like that. It was some kind of a gimmick that came out in the early 60s.
Well, the rocket radio was made by a couple of different companies. I'm pretty sure that's what you're talking about. I've had a couple go through the collection here, a couple originals and a couple of replicas. There was a company that was putting out pretty much exact replicas of the original at some point, and they worked. The first one I got came from my ex-father-in-law's family. He had found it in a drawer and gave it to me. And then I had bought a lot of handmade crystal and one-tube radios at one point, and gorgeous craftsmanship wooden pieces, and sent a lot of them down the line at various hamfests and such. And there were some of those replica rocket radios in there. And when you grow up in a town that has a couple of lower power, decent AM radio stations, crystal radios work great. So you can usually get enough selectivity to tune the 2 different or 3 different stations in. If you live too close to the tower, of course, that causes issues. But it can be definitely a good thing. And I was growing up in the Kingston area. The crystal radios always worked with a good length of wire on them, and I could listen to the stations. I had a couple really simple 1 and 2 transistor radios that worked as well. And you could actually, sit there and listen to a radio station comfortably on one of these things for an extended period of time. Another really interesting phenomenon in Kingston that I noticed is some of the the less selective radios would the shortwave and longwave ones would receive WGHQ and WKNY at the same time. You'd get both signals, one on top of the other, on 1490 minus 920 and at 1490 plus 920. Really cool mixing phenomenon. Never tested the range of it, but I assume it only occurred within a certain distance between the two stations. But neat stuff, Jim. And over to you for just one final good night, and I think we'll close things up.
Yeah, I think we pretty much exhausted the topic tonight. A lot of information out there and a lot of coverage and lots of things to think about and play with. And a good lead into future things to come when we start going up the band and start to talk about different technologies, going from the crystal set to vacuum tubes and transistors and ICs and so forth. A lot of stuff out there to talk about. Future topics. With that, I'm going to pass along 73s and let you wrap it up. K2BHF.
All right, Jim, and good night. And John UUI threw in a couple of things about listening to WMCA and ABC as a kid. Cousin Brucey, he lived a few blocks from him back then, and now Cousin Brucey, he says, has a house in Stone Ridge. And he said he was a DJ on a 1-watt college radio station, WFIT. Now he has internet radio and can supposedly get 1,000 stations. Well, I've often, done that analogy. Internet radio to me is like fishing in a spot where you can catch any fish you can think of. It's cool. It's neat. You'll love to see all those fish, but it's going to get boring really quick. This is W2NDG on the OMARC Sunday Night Science and Technology Net, running a little later than we usually run, but it was a good topic, and we're going to close things up now. We do meet here every Sunday night at 8 p.m., myself and my co-host Jim, K2BHM, and I am W2NDG. This repeater is sponsored by the Overlook Mountain Amateur Radio Club. You do not have to be a member of the club to participate in any of our activities or nets, but we do encourage you to do so. We're a friendly bunch of people. We love teaching, we love learning, and we love talking. Please join up with us if you haven't yet. You can find information about that at omarcclub.org, omarcclub.org. We hold 4 nets on this repeater regularly. Every morning at 8:35 a.m., Paul, AC2UQ, and a couple of other people, but mostly Paul, host the 8:35 on the 8:05 net. It is not really a directed net. It is a casual roundtable from anybody who checks in, where we just check with each other. What are we doing? How are we doing? Are we okay? Do we need any help? Do we need anything answered? Can we answer anybody else's questions? That's started for the COVID pandemic and continued into it, and we'll keep going because we like to be social, and when we can't be, sometimes we're not okay, and we need to talk. Every night at 6:30, a rotating group of hosts on OMARC hosts the 6:30 check-in net. Similar concept to the 8:35 net, but a directed net held by a net controller. We just check in. How'd your day go? Do you have any issues? Do you need any help? Are there any new members who want to check in? Every Thursday night at 8 p.m., our president, Dave, K2JLV, hosts the Thursday night OMARC Technical Net. Dave goes around the check-ins and asks if anybody has a particular technical subject. Wasn't aware that was going to happen. Every Thursday night at 8 p.m., Dave hosts the 8 p.m. OMARC Technical Net. After check-ins, Dave goes around, asks if anybody has any questions or particular problems they would like to discuss. If no questions or problems specifically come up, Dave spins the topic wheel and picks a good technical topic for the night. Anything from Raspberry Pi computers to how to build a balun to antenna radiation patterns, anything. And that's every Thursday at 8 p.m. And of course, this net is every Sunday night at 8 p.m. hosted by myself, W2NDG, and Jim, K2BHM. This is W2NDG on the OMARC 805 repeater, signing off for the night. We return the repeater to its regular use. As usual, I will hang out here for about 5 or 10 minutes if anybody has any questions. Everybody have a good night. Thank you. Ending YouTube stream now.